Hi there, I'm Sri Lankan. I'm your new science teacher. I teach science for both GC ordinary levels and for IGCSE curriculum. I'm from Gold, Sri Lanka. That's my name. I want you to watch my videos and I really want you to subscribe at the end of the lesson so that you can get to see my new videos coming. Today's lesson is Introduction to Refraction of Light. Before moving to the lesson refraction, shall we revise what we have done so far in this lesson up to refraction? Shall we? I think this lesson is going to be a very easy one for you because we have done a lesson in reflection and refraction in grade 9. We have learned almost everything that we are going to do in this lesson in grade 9, but only the basic idea. So this will be really easy for you to learn. Shall we talk about light? Light is a form of energy, but light is a special form of energy when compared with electricity and magnetism. Light is a form of energy that human eye is sensitive to. Not only human eye, but also eyes of other animals. Not only eyes, even some structures just like eye spots of organisms, just like eye spot of chlamydomonas. And under light we categorize things around us as, say, luminous and non-luminous objects. At the same time, we categorize things as transparent and translucent. Another thing about light is that light travels in straight lines in the medium. Light forms shadows when light meets an opaque object. I form a shadow here. And light reflects. What is reflection? Reflection is light bouncing back into the same medium when fallen on a surface. I've learned about formation of images. Maybe plane mirrors, maybe curved mirrors. They form images. Images can be, you have learned that erect or inverted. Virtual or real, and so on. Now, one of the very important points of light is this: light belongs to electromagnetic spectrum. That is, light is a part of electromagnetic spectrum. What is electromagnetic spectrum? Spectrum is basically a range, a graphical illustration of a group. So when you talk about electromagnetic spectrum, it is graphical illustration of all the electromagnetic waves in one place. So you remember electromagnetic spectrum, I think, in the lesson waves you learned in, say, cosmic rays, gamma rays, X-rays, ultraviolet, and then visible light comes with pure violet, indigo, blue, and red, and thereafter infrared, then microwaves, UHF, VHF, short waves, medium waves, and the long waves you have. So this is electromagnetic spectrum. These are the things that you have learned so far. So shall we go to the lesson refraction? You have learned that light travels in straight lines, but remember, only when light passing through one medium, a single medium. What happens when the light changes the medium? Don't know. But light travels in straight lines when light passing through one particular medium, through a single medium. To see what happens when light changes the medium, shall we do some activities? Watch carefully. the block of glass distorts the letters, and the glass of water changes the direction of the laser beam passing through it. This is an animation of a cheetah on my computer screen. And what I'm going to do is to place a glass in front of cheetah. Now what I do is I put some water into the glass. See what happens. Cheetah changes the direction. Why is that? Light bends when passing through different media. That's it. The activity showed you that light changes direction when traveling through different media, or when light going from one medium to another. So these media are transparent. But in physics, in science, we call these media differently. We don't say that transparent medium. We say an optical medium. An optical medium is a medium through which light can travel. So it is good to say light bends when going from one optical medium to another. That is really refraction. We will learn it later. One thing that you should try to understand is this. When light passing from air to water, it bends, you know that. When light passing from air to glass, it bends, but differently. It bends readily. Why is that? Optical media should be different. There should be differences in them. What sort of difference can be found in different optical media? There is something, that is what we call optical density. In other words, the water has one particular optical density, and it is different from the optical density of glass. What is optical density? What do you mean by optical density? When you talk about density, you would think naturally that density is mass per unit volume. Or you would say that density is mass divided by volume. That is the general density of material. It is not optical density. Optical density and the general density are quite different things. I'll give you a very nice example. You know paraffin. Paraffin is a liquid, a transparent medium, and optical density of paraffin is really very high than that of water. That is, optical density of paraffin is higher than that of water. Optical density of paraffin is higher. Optical density of water is lower. But if you put paraffin into water, what happens is that paraffin floats on water. Why is that? Paraffin is lighter. Water is denser. So in general density, the water is the denser one and paraffin is the lighter one. But when it comes to optical density, paraffin is basically have high optical density and water has low optical density. That's it. That's what we call optical density. One thing I forgot to tell you about optical density is this. Just think about your own ground. So you can run fast. But if you jump into water, you cannot do that, you know, right? You become really, really slow. So when you change the medium, your speed becomes different. The same thing happens to light. When light traveling through different media, the speed of light becomes different. If the optical density is high, light finds it very difficult to pass through. If a material has a very low optical density, light can go through that easily. One thing goes with this optical density is rare medium and dense medium. It's just like this, you have learned that. When you compare rubber and wood, you would say that wood is hard and rubber is soft. When you compare the same wood and iron, you would say that iron is hard and wood is soft. It's something like that. When you compare two optical media, the media with low optical density is rare medium. The medium with high optical density is dense medium or dense medium. That's it. So, in that sense, when you compare water and air, air is rare and water is denser. When you compare water and glass, glass is denser and water is rare. So you cannot exactly say whether water is rare or denser without thinking another medium. When light passing from one medium to another, one optical medium to another optical medium, we have to consider the optical densities of the relevant particular media. Just talk about the two words rare and dense. That's it. Let me summarize what we have done in this lesson, Introduction to Refraction. When light passes through a medium, we call it an optical medium. When light passes through one particular medium or a single medium, light travels in straight lines. When light going from one optical medium to another, light bends. So finally, shall we think about a definition for refraction? Refraction is bending of light when passing from one optical medium to another. Bending of light when passing from one optical medium to another. That's everything for today's lesson. See you next time with an activity explaining why light bends and laws of refraction. I think this video helped you, and thank you very much. Subscribe. Bye.